All right, pre-calc, we're going to do some extended trig, and really the idea is, you see I have up here circular functions. We're going to start getting the idea that these trig identities, the right triangle trig stuff, they're more than just that. So we're going to have a few things to deal with. All right, so in our angle measurements, we're always going to have an initial side and a terminal side, right? So if we start at one side, we go to the other one, just some vocabulary. And what's going to happen as we look at the x-axis is always going to be our initial side, and wherever we end up, this is going to be our terminal side. Okay, so wherever we end up. Now, if it's positive, so we're going to work this way. If it's negative, then we're going to work clockwise. Okay, counterclockwise versus clockwise. So these are our negatives. Okay, so vertex is at the origin, and initial side is always on that positive x-axis. So those are kind of important things as we get started. All right, any angle measurement that we're going to deal with. So I'll be honest, the one thing that I was like, I don't really like this whole idea of dealing with negative angles. So what we're going to do is we're going to give you a way so you don't have to deal with that at all. Okay, but we want to make sure that we're always dealing with one circle. Remember, we had a carousel problem where we're going around and around for 3 minutes. We found out that we went 9,036 degrees, and I was like, well, how many times is it? So all we did was divide it by 360 to figure out how many times, and that one happened to be like a nice number. But if it's not a nice number, or if it's negative, right, we don't really go backwards on the carousel. That would make me sick even faster. What we do is we just change it so it has exactly the same. So let me show you how that works. If we're dealing with name the quadrant, the angle is in standard position. Okay, so here's what we have. So here's our 0, right? And we're going to do is we're going to go, it's positive. So we're going to go along the top. So here's 90. All right, and I'm not going to make it to 180. These don't have to be to scale, but I'm going to be right here. Okay, so what happens is this is quadrant 1, this is quadrant 2. You get the idea. So we're in quadrant 2. Okay, so I just want to know which quadrant I'm in. All right, now, negative 225, I'm like, what? I don't like that at all. Well, let's figure out what's going on. So I could find the same thing if I just add 360. So if I add 360, I'm at 135 degrees. So I can work with all of these only in the positive direction. Okay, so I'm going to start here, and I'm going to go 90. All right, so 135, that's going to be back over here. So I'm in quadrant 2 again. How about that? What about negative 405? Well, remember, I don't like negatives, so I'm going to do this first. So I'm at negative 45 degrees. But look at that, it's still negative. So let's just add 360 one more time, and that finds me at 315 degrees. Oh, wow. So the whole circle, remember. So here's where I'm going to start. 90, 180, 270. Oh, so I got to be in here somewhere. So I'm in the 4th quadrant. Okay, so I'm always going to work off of that x-axis. You're like, wait, 3 pi over 4. Whoa, whoa, whoa. You're messing with me here. Okay, so remember that pi is 180. So what we really need is 3/4 of 180, which would be 135. So where are we at 135? Well, here's 90. So I'm somewhere in here again. So I'm in the 2nd quadrant. That's supposed to be a 2. All right. So here's what we're dealing with. So we can go multiple times around, but like I said, we're going to try and avoid that. We're going to get rid of any multiples of 360 and any multiples of 2 pi. We're just going to try and avoid those because mathematically we can. So I don't really need to deal with that. All right, so coterminal angles. 2 angles that share the same initial sides. Well, we actually get into that right here. Okay, so negative 225 and positive 135 are coterminal. Why? Because they have the same initial sides and the same terminal sides. So that's how we're going to deal with them. Angles are coterminal when they differ by an integer multiple of 360 or 2 pi. Okay, so examples, 150, and then we have 150 plus 360. Take a guess. 512. What if I did 150 minus 360? I'm going to get negative 210. Okay, so for our purposes, we typically always want to work something between 0 and 360 And we also want it to be positive. So we're going to use this rule kind of any which time we want so that things work out very, very nicely for us. All right, so let's see how that works. Finding coterminal angles. Okay, we want to find and draw a positive angle and a negative angle that are coterminal with the given angle. All right, so here's the deal. I'm going to start at 30 degrees. I'm going to add 360. Where am I at? I'm at 390 degrees. Okay? The truth is I would never change 30 degrees because that's the thing I really want to work with. So all we're really going to do is whatever the angle is, we're going to do plus or minus and figure out where we would be. Okay, so that means 30 degrees, 390 degrees, and negative 330 degrees are all in the exact same location. All right, so hopefully you get the idea. We're going to do negative 150 plus 360, or negative 150 minus 360. All right, so we should be at 210 degrees and negative 510 degrees. So negative 150, positive 210, and negative 510 are all in the same location. All right, radians. Let's see, 2 pi over 3 plus 2 pi and 2 pi over 3 minus 2 pi. All right, so remember, we're dealing with some fractions. These are over 1, so we have to make some common denominators, and that common denominator is going to be 3. So this, if this goes to 3, this will be 6. All right, so we're going to find out if it's 8 pi over 3. And this will be 6, and this will be 3. Okay, so we're going to get negative 4 pi over 3. Now, by all means, what we can do is you can find 2/3 of 180 and deal with it that way. But I felt since it was in radians, we should also show you how to deal with it in radians. Okay, so that means we have the exact coterminal. All right, now the next thing we have to deal with, now that we understand where angles are, is a reference angle. Okay, and what we'll do is reference angles are always going to be between 0 and 90. So this is technically getting to the idea that we want to put everything kind of within the first quadrant, but it might be in a different location. Okay, so it must be with a coterminal angle of a positive measure between 0 and 360 and locate the reference angle. So we're going to do the same thing we just did. All right. So 35, I don't want to mess with 35 at all. And notice what happens is I have this. So let's use the graph down here and say it's 35 degrees here. And I want to use exactly that. So my reference angle is 35 degrees because it's between 0 and 90. We're going to leave it exactly the way it is. That angle is that angle. And then what happens is 145. So we did this one before. Right? So here's my 90. Here I crossed over 90, but I'm not going to cross over 180. So I have this. This is my 145. Now here's the key, guys, is everything that I want is based on the x-axis. Okay, so that means the reference angle is going to work back from there, so it's 35 degrees. Okay, but we're in quadrant 2. Okay, this is quadrant 1 using the same idea we had before. All right, the next one, negative 225. No, I'm not playing negative 225, right? We're going to add 360. So the angle measurement we're dealing with is 45 degrees. Well, 45 degrees is going to be right around here, right? So my reference angle is 45 degrees, and we are in the first quadrant. What about 445? Well, that's way too much. I want to get rid of 360 of those because I want to find out where I'm really located, and that's 85 degrees. Well, 85 degrees is still in that first quadrant, so my reference angle is going to be 85 degrees. All right, which one didn't we get? We did not get one of these down here. So let me just point it out because we did quadrant 2, right? Quadrant 1's pretty easy, right? Because the reference angle is the angle we're dealing with. Remember I said that everything is going to be based on the x-axis. So when I end up in quadrant 2, I really want how far I am from the x-axis. When I end up in quadrant 3, okay, so that means we were more than 180 but less than 270. Now you don't have to memorize those numbers, just keep an idea of where we're at. Notice my distance, my reference angle is how far away I am from the x-axis. And in the last one here, we're going to make it into that fourth quadrant, which I thought I had one of these. Oh, not yet. We're going to do that in a little bit. So I'm going to work my way the whole way around it, but still what I want to know, so I'm more than 270, less than 360. My reference angle is how far I am away from the x-axis. So if that helps, I do have a little formula sheet on the side here, if that helps or not. But I think if we just go with the idea of how far am I away from the x-axis in degrees, that's going to make this whole idea come together a little bit better. All right. So let's take a couple look at a couple of these, and then we'll leave the other ones so you have something to work on as well. All right, so 7 pi over 12. So first things first, that's 105 degrees. Okay, so how did I get that? I did 7 divided by 12, and I took it times 180. Okay, now where is that going to be located? Well, that's in quadrant 2, somewhere in here, right? Because this was 90 degrees. So we're in quadrant 2. Is that all it says? Stanford given the quadrant is the terminal sign. Okay, so that's all we need for that one. Okay, and we'll take out the negative one here. We'll say plus 360. And that puts us at 204 degrees. Now, where am I going to find 204 degrees? Well, here's 90, here's 180, so I'm in the 200 somewhere in here. That puts me in quadrant 3. Okay, so these are just about the quadrant. Find one positive angle, one negative angle. They're coterminal with each angle. Okay, so this is plus or minus 360 or plus or minus 2 pi. Okay, remember, we want to use the 2 pi, not just pi, because the 2 pi is getting the whole way around it. All right, then the next thing we do is find that reference angle. So this is the one that's most important as we move on a little bit. So first things first, we don't really want the negatives. All right, so we're going to add 360. Okay, we'll find out that we are located at 340 degrees. So where am I going to find 340 degrees? And way back here, right? So I'm in the fourth quadrant. But what I really want to know is how far off of the x-axis am I? So I'm going to work my way back here. So this is my reference angle. And what I'll find is that I'm 20 degrees away from it. How did I get it? Well, that was 360 minus the 340, which is our difference. All right, and the next one, we got 10/3 pi. So first things first, let's make that 600 degrees. But that's way too much, right? So let's get rid of 360. So we're at 240. So if I'm at 240 degrees, where am I located? At 90, 180. I'm not going to make it to 270, so I'm somewhere in here. And remember, my goal is always, my reference angle is how far am I off of the x-axis. So this angle right here is going to be 60 degrees. How did I get that? 240 minus 180. Okay, so if we can identify that I always want to work off the x-axis, I think this makes it a lot easier for you. Okay, so we have some matching down here. So maybe changing some degrees and radians back and forth as we work on that. And the faster we can make some of those conversions, if we do some of them in our head, then we're going to be in pretty good shape. Okay, so I left this just as a little matching to see how well we can get through some of those. All right, so here is another graph of the same thing. And I just want to point out, this one's in color, so it's really nice, that we're always working off of the x-axis. Okay, so I'll highlight the things that I think are most important. And when I bring it out and we highlight it that way, then I don't really need this chart over here, right? Because I just want to find out how far off the x-axis I am. So I don't have to be bogged down with plus or minus from 180 or whatever I'm trying to work with. It just makes that a little bit easier. Okay, so let's make sure we have just a couple more here. Again, I'll continue to work on the right-hand side, and we'll do more of this in class as well. Okay, 185 degrees, so 90, 180. Okay, so that means we just made it past our 180. Okay, so our reference angle is only based on how far off of there we are. So 5 degrees, and we're in quadrant 3. Okay, 621. All right, well, let's get rid of 360 of those degrees. So that's going to put me at 261 degrees. Okay, so here we are. We're at 90, 180. All right, so 270 would put me here, right? 270 would put me straight down. So I'm not there, but the question still is, how far off the x-axis am I? So that means from 180, where are we at? And that's 81 degrees. We're in the third quadrant again. I don't know why all my examples are in the third quadrant, but you know, I think that's pretty good. So why don't I grab number 2 here? Let's take a look at this one real quick. You can pause it and take a break if you need to. All right, 360 would be almost the whole way. So we're not going the whole way, so we're going to be short that. Okay, but remember, my reference angle is how far off the x-axis I am. So 360 minus 322 would be 38 degrees, and we're in quadrant 4. Okay, so always go off of the x-axis. That's going to make our life so much easier, and then we'll have all the same answers, which is usually pretty good. All right, I just want to throw this one out there. I got rid of all the extra examples, but anything that says listing all the angles that are coterminal, okay, so we're going to use an equation for it, okay? So if it's 120, that means we're going to go plus or minus 360. But that would only give me one of them, so I would also define n if n is an integer. Okay, if it's radians, 3 pi over 4 plus or minus 2 pi times n, as long as n is an integer. So we're identifying it that way. All right, and then we got a little practice here. So just be mindful of what we're asking for. Draw angle in standard position. Remember, that's off of the x-axis here in the quadrant in which it terminates. Okay, so that's all we need for that one. And then as we move forward here, we want the reference angle. So we still may draw those and kind of work backwards, and then eventually we'll get away from those. All right, so we'll keep working on that. This will all be part of the homework, but if you're comfortable and you know what we're doing, then go ahead. Otherwise, we'll work on it in class and then progress from there.